So guys, we are starting with some more problems of domain and range. So the question is, find the domain of f of x is equal to root of 1 minus 2x minus 3x square. Now within the root, whatever the value is there, it has to be positive or 0. It cannot be negative. Okay, it cannot be negative. So here is the terms minus 3x square minus 2x plus 1 greater than or equal to 0. Take negative 1 common over here. So 3x square plus 2x minus 1 greater than or equal to 0. Now divide the negative 1 on the right hand side. Okay. So the sign is going to change. It will not remain same. Whenever we are dividing with a positive or negative number, whenever we are dividing or multiplying with a positive or negative number in inequalities, the sign changes. So factorize this. So see, there is a sign change and we can factorize the left hand side. So if we factorize the left hand side, you'll get 3x minus 1 into x plus 1 less than or equal to 0. Now we need to get the critical values. Equate the first bracket to 0. We'll get the first critical value of x as 1 by 3. And equate the second bracket to 0. We'll get the second critical value, that is minus 1. Okay. So these are the critical values, 1 by 3 and minus 1. Let's put this critical values on a number line. Okay. So this is 1 minus 1 and 1 by 3, negative infinity and positive infinity and negative infinity. Okay. Now see guys, there are three regions over here. We need to select any one point within the regions. So let's take 0. Fine. 0 represents region number 2. So put x equal to 0 in 3x minus 1 into x plus 1. We put the value of x, okay, in the left hand side, right? So this is equal to 3 into 0 minus 1 into 0 plus 1, right? So this is minus 1 into 1, which is minus 1. So for 0, we got a negative answer. This entire region is negative. Adjacent region will be positive. Okay. Now check out for the inequality. It is less than or equal to 0. Less than or equal to 0 indicates lesser than or equal to 0 indicates negative region. So x will lie between minus 1 and 1 by 3. Okay. So the domain is x belongs to minus 1 and 1 by 3. Put a box bracket. And there is no denominator over here to analyze it further. And since there is equal to sign, minus 1 and 1 by 3 are inclusive. They are included. Fine. So that was one of the questions. Let's go to the next problem. F of x is equal to 10 raised to x. We need to find out the domain. They're asking you the domain only for this particular problem. Now x can be 0, x can be any positive value, x can be any negative value. So 10 raised to 0 is 1, 10 raised to any positive value. So let's say 10 raised to 1 is 10, 10 raised to 2, it's 100. Okay, 10 raised to half, it's root 10. So we are getting the answers, right? And let's take some negative one. 10 raised to minus 1 is 1 upon 10. 10 raised to minus 2 is 1 upon 10 square, which is 1 upon 100. So for the negative values also, we are getting the answer. So we are getting values. We are getting the answer of 10 raised to x when x can be 0, negative or positive. So the domain says x belongs to all real values. Okay. So the next question. They are asking you the domain of f of x is equal to log 2x minus 3. Now log value, the value of this particular bracket, log never takes up 0 or negative values. So log value, the value is 2 minus 3x. The value is always greater than 0. It can never be less than or equal to 0. So 2 is greater than 3x. Okay, this implies 3x is lesser than 2. Now divide by 3. Now since we are dividing with a positive number, there is no sign change. So x is lesser than 2 by 3. So 2 by 3 is over here, lesser than 2 by 3. It can go up to negative infinity. Okay, so x belongs to 2 by 3 and we have negative infinity over here, round bracket. And since we have only less than, we don't have equal to. So 2 by 3 is inclusive. Sorry, not inclusive, since there is no equal to sign. Fine. One more question. F of x is equal to log of root of x minus 4 plus root of 6 minus x. Now this value, the value of this log within the round bracket, it cannot be negative. So root of x plus 4 plus root of 6 minus x. Okay, it is always greater than 0. Fine. Okay. Now see, within the root, we are having two values. Now these two values, okay, these two values are supposed to be greater than or equal to 0. The values within the root cannot be negative. Okay. So x is greater than or equal to minus 4, and here 6 is greater than or equal to x, which implies x is lesser than or equal to 6. So we got two conditions over here. X less than or equal to x greater than or equal to minus 4. Uh, just a second, I think I have copied the question wrong. It is minus over here. Okay, sorry. So x is greater than or equal to 4 or x is less than or equal to 6. Now on a number line, let us understand this. We have 4 over here and we have 6 over here. X is greater than or equal to 4. So all these values up to positive infinity. And x is lesser than or equal to 6. All values till negative infinity. Right? Now the thing is, what is the common region over here? See, look at region number 2. This is region number 1, this is region number 2, and this is region number 3. So above region number 2, there are two lines. That means both the conditions are satisfied over here. Above region number 1, there is only one line. That means only one condition is satisfied. And above region number 3 also there is one line. That means only one condition is satisfied. But then above region number 2, there are two lines. That means both the conditions are satisfied over here. So x will lie between 4 and 6. Okay, but then why are we including the values of 4 and 6 is because we can also write like this, because we have equal to in the problems. In the problem, we have equal to in the problem. Fine. So that was one of the questions that you need to know. Then let us go to question number 7. Next question. Find the range. This time they are asking you range of f of x is equal to modulus of x minus 3. Now x minus 3 modulus will take up what all values they are asking you. Now the critical point over here is 3, because 3 minus 3 gives you 0. Okay, so x can be equal to 3, x can be more than 3, x can be less than 3. Okay, so if 3 is over here, so x can be 3, x can be more than 3, x can be less than 3. So when x is equal to 3, f of x is equal to 3 minus 3, which is equal to modulus of 0, which is 0. Now x is greater than 3. X is greater than 3 for first value. Let us test for x is equal to 4. So f of x is equal to modulus of 4 minus 3, which is modulus of 1, which is 1. If x is equal to 3.5, f of x is equal to 3.5 minus 3, which is equal to 0.5. Okay, right? So we are getting certain answers over here for x is greater than 3. And all these are real values. Okay, then when x is less than 3, let's take x as minus 4, x equal to minus 4. So f of x is equal to modulus of minus 4 minus 3, which is equal to 7. Let's take x as minus 3.5. So f of x is equal to minus 3.5 minus 3, which is equal to 6.5. Okay, let's take x is equal to minus 6, for example. So this is minus 6 minus 3, 9. So we are getting some real values over here. Okay, and we are also getting 0. So all these real values are positive. See, observe 1, 0.5, okay, 7, 6.59. These are positive reals, and 0 we are getting. So we are not getting negative reals. Okay, so the answer of f of x, we are targeting f of x over here because we need to find out range, and range is y is f of x. So y belongs to 0 to 0 and all positive real values. This is union I have written. Okay. Uh, this can also be written as y belongs to 0 to positive infinity. Infinity is round bracket. Okay. And y is 0 as well. So 0 comma infinity. That's the range. Okay. Let's go to one more problem, that is uh, we need to find out range over here in this particular problem. Okay. F of x is equal to cos x by 3. See now, sine theta or cos theta. Sine theta or cos theta, the values always lie between minus 1 and 1. You should remember this from the trigonometric functions. Whatever answer of sine and cos is there, it is always between minus 1 and 1. So here theta is x by 3 in our solution. Okay, so the value of this will always lie between minus 1 and 1. See, there is no rocket science over here. You just need to remember that cos value always lies between minus 1 and 1. And this value is nothing but y, and y is nothing but f of x. Okay, so the range y belongs to minus 1 comma 1. Okay, similar thing is for sine. You need to remember this. Okay, yeah, and we are putting box bracket just because there is equal to sign over here. Now one more problem, f of x is equal to root of x minus 5. Here also range you need to calculate. Now see, x minus 5 is within the root, so the value is always greater than or equal to 0. Take square root. Its square root will also be greater than or equal to 0. We cannot take negative, we cannot take negative value of the root, because in the previous sessions I have already explained. Okay, if we take the negative value of the roots, then x will have multiple images. Okay, this is x, this is y. For example, if we take x as 9, so the answer will be root of 9 minus 5, which is root of 4, which is plus or minus 2. Okay, so we'll have multiple images over here. So don't take the negative value of the root. Okay, yeah. So root of this is uh, greater than or equal to 0. Why are we interested in root is because we have a root over here. So f of x, this is nothing but f of x, and that is y greater than or equal to 0. Y belongs to 0 to infinity round bracket, and this is box bracket. Okay, yeah. So yes, this was one of the problems that you need to focus on. One more question. We need to find out domain and range both over here. X square minus 4 upon x minus 2. Now domain part. Observe the denominator. Denominator cannot be 0. See, there is no square root in the problem. So forget about greater than, less than. If it is a fraction, the denominator cannot be 0. So x cannot be 2. Okay. So domain, x belongs to any real value except 2. Okay. Now y is equal to x square minus 4 upon x minus 2. Y is equal to x plus 2 into x minus 2. Cancel out the x minus 2 over here. So y is equal to x plus 2. Okay, this much we know. Now we cannot take x value as 2. If we put the value of x as 2 over here, if x is equal to 2, y is equal to 2 plus 2 is equal to 4. Okay, equal to 4, right? If x is 2, y value is 4. And if x is not equal to 2, y can never be equal to 4, right? Then what is the value of y? Y will be any real value except 4, and that's the range. This is the range calculation. See, again, I'll explain. This is y, which is x plus 2. Now, if x is equal to 2, we are considering this case. If x is equal to 2, y value will be 4. But then x can never take this value 2. Then y can never be 4. Okay, so y will be what? Any real value except 4. That's the range. So there is one more question. Function of x is modulus of x upon x. The domain of this function, that means the values of x, they lie between 3 comma 7. We need to find out the range. Okay, range is nothing but the value of y. Now y is modulus of x upon x. Now see, let's take case 1. Let's take x as 3. So y will be modulus of 3 upon 3. If you calculate this, it will be 1. Let's take x as 3.5. So modulus of 3.5 upon 3.5 will be 1. Let's take x as 7. Y will be modulus of 7 upon 7, which is 1. Let's take x as 6.9. Y will be modulus of 6.9 upon 6.9, which is 1. So everywhere the answer is 1. So the range for this problem is y belongs to 1. Only one object. So that's the final answer. Okay. That's the end of domain and range. Okay, guys. Thank you.